Chonnam National University Research Highlights, Episode 10. How can orchard robots stay precisely localized when dense canopies weaken GNSS signals and orchard rows look alike? Drone imagery provides aerial context while ground LiDAR captures detail, but its trajectory can drift. Both sources become local maps, an RSI aerial map and a LiDAR bird's-eye view. A transformer-based network learns modality-invariant structural cues and predicts a pixel-level flow field between RSI and LIO. Multi-scale refinement then aligns the aerial and ground views across their different sensing modalities. The flow creates geo-localization and loop closure factors for pose graph optimization, correcting drift and maintaining global consistency. Aligned aerial and ground data form a GIS-driven multi-layer orchard model for tree height estimation and tree-scale phenotyping. Validation across 3 orchard areas confirmed centimeter-level matching and reconstruction performance. Accurate tree height estimation and suitability for embedded real-time operation support, next-generation orchard management. This study was published in the journal Artificial Intelligence in Agriculture.